We are going to learn about logarithms, one of the easiest concepts in mathematics.
This ain't easy.
Logarithms is just another way of showing or expressing the exponentials. So when I say 10 to the power of 2 equals 100, I can show that by this symbolism. Logarithm or log of 100 with the base 10 equals 2. So these two expressions are equivalent. 10 to the power of 2 equals 100 is the same as log of 100 with the base 10 equals 2. So one thing you need to remember is that log has a base, has an answer, and there's one thing in front of the log. Log is a code, and to decodify it, here's what we do.
Codes, battle.
The base, which is 10 in here, to the power of the answer of the log equals what's in front of the log. The base to the power of the answer of the log equals what's in front of the log. And here's one way to remember that. So we say base to the power of the answer of the log. So base starts with B, answer starts with A. A, B, C, A and B always are near each other. So base to the power of the answer equals what's in front of the log. A and B are near each other. That's how you can remember what a log means. Let's see now some examples. So can you show this expression 10 to the power of 3 equals 1000 in the log format? So base to the power of the answer, so I know log, the base of the log is 10, and the answer of the log is 3, because we say base to the power of the answer, so the answer of the log is 3. What's in front of the log? 1000. So these two are equivalent. How about doing the reverse? Can you show this with exponentials? Log of 10,000 with a base 10 equals 4. Show this as an exponential. So you say the base of the log, base to the power of the answer of the log, 10 to the 4, equals what's in front of the log, 10,000. That's it. Let's see some more examples. Log of 8 with the base 2 equals what? Suppose we wanted to find the answer of that log. So again, we use the definition of the log, what this code means. Log means the base, which is 2, to the power of the answer of the log, which is, we don't know, is question mark, equals what's in front of the log. So here's what we have to find. 2 to the power of what equals x? 2, how many times multiplied by itself would equal 8? So we know 2 multiplied by 2 is 4, multiplied by another 2, that's 8. So that's 2 to the power of 3. So question mark is 3. That's the answer of the log. Let's see another example. Log of 27 with the base 3 equals what? Again, we use the definition of the log and say the base of the log, 3, to the power of the answer of the log, question mark, must equal what's in front of the log, 27. All right, let's see. So 3 times 3, that's 9. 9 times 3, that's 27. So that's 3 to the power of 3. Again, the answer of the log is 3. That's how it works. You can solve these, simplify these, and convert from the exponential form to the logarithm form by using the definition of the log, that mantra that I told you. The base to the power of the answer of the log equals,
wait for it,
what's in front of the log. All right. What about natural logarithm? Natural logarithm, we show it by ln. Why not nl? Natural logarithm. Because in Latin language in the past, the adjective comes next. Logarithm natural. So ln, that's natural logarithm. And this is exactly natural logarithm of x equals, it's the same concept, log of x. Just the base of logarithm here is a special base, e. E is a number just like pi. It never ends. The decimal in e never ends. It's just 2.7 something something something. It's a number that can be found in when you calculate compound interest. We're going to make a separate episode about that. So now let's see some examples with natural logarithm. So natural logarithm of e to the power of 2 equals what? Let's use the definition of log to find out. So log means the base to the power of the answer. What's the base here?
The rhythm is the bass and the bass is the treble.
There's no mention of base here. Well, here's the base. It's hidden. Natural logarithm means a logarithm with base e. E is 2.7 and never ends. The decimal points never ends. It's called Euler's number. Alright, so again, using the definition of the log, we mean base of the log, which is e, to the power of the answer of the log, which we don't have, it's question mark, must equal what's in front of the log. So must equal e to the power of 2. Interesting, e to the power of, we don't know, must equal e to the power of 2. So what you don't know must be 2. So question mark equals 2. So that's how easy it is. Natural logs are just like logs, no difference, just the base is now e, the Euler's number. What if in a log they don't mention the base, just they say log of 10 to the power of 5? What about that? Whenever they don't mention the base of the log, that means the base is 10. So it is common that when the base is 10, they don't mention it. Just like square roots. When you have a square roots, the degree of the root is not mentioned. We don't put 2 in here when it's square roots. So this is the same. When the base of the log is 10, it's often we don't mention it. But again, we use the definition of the log to answer this. So the base of the log, that is 10, to the power of the answer of the log, question mark, equals what's in front of the log? 10 to the 5. There we go. Question mark equals 5. 10 to the power of what equals 10 to the power of 5? 5. So that's the answer of the log, 5. Let's see some more examples. Suppose we have log of the 5th root of 2 and the base of the log is 2. What's the answer to that? How would you simplify that? Let's start by writing the root as an exponential. So I say log of, instead of 5th root of 2, I say 2 to the power of 1 over 5. So we have already gone over the roots and what they mean. You can find a link in the description on the top right side. It will pop out. Where the base of the log is 2. So I can write that as 2 to the power of 1 over 5. That's the 5th root of 2. Now, let's use the definition of the log. So this we want to find out. The equals question mark. I know that the base of the log to the power of the answer of the log equals what's in front of the log. 2 to the power of 1 over 5. So the question mark then must equal, question mark must equal 1 over 5. That's it. That's the answer. And in fact, as a rule of thumb, always when you have log of something that is equal to the base, for example, you have log of x and the base of the log is also x, that always equals 1. When the base and the log are the same, when the base and what's in front of the log are the same, the answer is 1. And now if what's in front of the log is raised to a certain power. For example, if you have log of x to the power of n, and the base of the log is x, the answer is n, just like we saw in here. Log of 2 to the power of 1 over 5, and the base of the log was 2 as well. The answer was 1 over 5. Let's see another example. Log of square root of 7 with the base 7. Alright, let's deal with the square root first and write it as an exponential. So that equals log of 7 to the power of 1 over 2 with the base 7. So we said when what's in front of the log is the same as the base, the answer is that exponent. So the answer here is 1 over 2. Or you can use the very definition of the log to arrive at that conclusion as well. Let's see another example. Log of 225 with a base 15 is what? So whenever you see these kind of questions, you must have speculate that what's in front of the log, that is 225, must be a multiple of the base. So let's divide 225 by 15. And when you do that, you realize 225 equals 15 multiplied by 15. In other words, 15 to the power of 2. So I'm going to write that as log of 15 to the power of 2 with the base 15. And the answer is 2. Let's see another example. Let's convert this number, this exponential, 3 to the 5 equals 243. Write this in the log form. So I say log, and I know I have to fill out these 3 positions, right? So the base is what? This is the base, 3. What's in front of the log comes here. That's it, 243. And the power, this one, is the answer of the log. That's it. Now let's summarize all the log rules that would help us to simplify exponential expressions and deal with logarithmic algebraic equations. So the first rule is called product rule. So if I have log of the product of 2 terms, like x multiplied by y, and the base of the log would be b, the answer to that is, I can write that as log of x with a base b plus log of y with a base b. So I can convert product or multiplication into summation or addition.
What an astounding product!
The other rule is called quotient rule. So if I have log of x divided by y with a base b again, I can write that as log of x with a base b minus log of y with a base b. So I can convert division into subtraction. Next will be the power rule, which we already mentioned. If you have log of x to the power of n, the base of the log is b, I can write that as n multiplied by log of x with the same base, b. What if the base has a power? For example, we have log of x to the power of n, and then b has a power of its own, b to the power of m. How do you simplify that? So that we can write as n over m multiplied by log of x with the base b. So all of these rules can be derived from the very definition of the log, and we will prove them in a separate video. Now, if you have a number raised to the power of a number like b raised to the power of a log with base b, so a number raised to the power of the log with the same base as that number, and then what's in front of the log is just x, that you can write as just x, simplifies as just x. If you have log of a number like x, and then the base of the log is also the same as x, then that will amount to 1. Log of 1, on the other hand, is always equal to 0. So the base could be anything. Log of 1 equals 0, because numbers to the power of 0 equal 1. Let's see some more rules.
Nothing more fun than rules.
So we have two logs multiplied by each other. Log of x with a base b multiplied by log of b with a base y. This equals to log of x with a base y. So you can think of it as these base b cancel off, and then you get log of x with the base y. So if I divide both sides by one of the logs in the left hand side, I can write this rule as a division. I can write log of x with a base b. I can write that as log of a fraction on the top, log of x with a base y over log of b with a base y. So sort of the bases on this fraction cancel off, if you wish. Now let's mention some common rules that you will see often.
More rules.
For example, log of 1 over x with a base b, that's equal to negative log of x with a base b, or to log of x with a base 1 over b. And you have to notice that in all these logarithms, the base of the logarithm is defined as a positive number, so it must be greater than 0, and it must not equal 1, because 1 to the power of anything is 1, so they exclude 1 from logarithm. And you may ask why there are such rules. There's another rule that says what's in front of the log, like whatever x and y that we mentioned that were in front of the log, they also must be positive. So you might say, why we have these rules, and then these are the rules of the game of logarithm. So somebody invented logarithm and they set these rules. Just like chess has some rules, you cannot ask why.
There's no but in a military situation.
You can ask, and it has to do with the game being more exciting. And sort of similar reason is applicable in here. So base of the log is always positive and always not equal to 1. And what's in front of the log must always be positive as well. Now let's see some more examples. Simplify this. So I can say equals log of, let's deal with the cube root. So I can say x to the power of 1 over 3 over 36 is just 6 to the power of 2 times y to the power of 4 with the base 6. Okay. Now remember, we could convert division into subtraction, the quotient rule. So I can write this as log of x to the power of 1 over 3 with the base 6 minus log of 6 squared times y to the 4 with the base 6. So this second logarithm, I can write this product, the multiplication of 6 squared times y to the 4, as addition. So I can write this part as log of 6 to the 2 with the base 6 plus log of y to the 4 with the base 6. So if I write it all in one line, that will be log of x to the power of 1 over 3. I can bring power to the back of the log, use one of the rules. So it becomes 1 over 3 log of x with the base 6. Now minus, so log of 6 to the power of 2 with the base 6. That will just simplify it into 2. Because log of 6 with the base 6, that's 1. And the 2, we can bring it to the back of the log. So 2 times 1, that's 2. So 2 plus log of, or the power of 4 can go at the back of the log. 4 log of y with the base 6. Excellent. So now let's distribute this negative into the parentheses. So I have 1 over 3 log of x with the base 6 minus 2 minus 4 log of y with the base 6. So now I can write 1 over 3 log of x with the base 6 right beside the other log minus 4 log of y with the base 6 minus 2. Now let's see another example. Find x. So you use again the definition of logarithm. You say the base of the log, which is 4, to the power of the answer of the log, which is 2, must equal what's in front of the log. So that's 3x minus 5. There it is. Now it's a first degree equation, linear equation. So 4 to the power of 2, that's 16, equals 3x minus 5. So I take all the numbers to one side. So minus 5, or I could say I add 5 to both sides of the equation. So I have 21 equals 3x. Divide both sides by 3, x equals 7. Let's see another example. Find x. Again, using the definition of logarithm. 4, the base of the log, 4 to the power of the answer of the log, which is 5x plus 3, must equal what's in front of the log, which is 2 to the power of x. Alright, so I can write 4 as 2 to the power of 2. So let's do that. I can write 4 as 2 to the power of 2, and then to the power of what it was outside, 5x plus 3 must equal 2 to the power of x. So the power outside of the parentheses gets multiplied by 2, so you get 2 to the power of 2 times 5, that's 10x, 2 times 3, that's 6, must equal 2 to the power of x. So in here the bases are the same, so the powers must be the same too. So again you get a linear equation. 10x plus 6 must equal x. So I subtract both sides by an x. So it becomes 9x. And I subtract both sides by 6. So 9x equals negative 6. Divide both sides by 9. X equals negative 6 over 9. Or it just simplifies as 1 over 3. Negative 1 over 3. That's the answer. Let's see another example. Find x.
Let's solve for x.
So we can see in the bases they have something in common. They're all based on 5. So the first one is just log of x with the base 5. The second one I can write log of x with the base 5 to the power of 2. And the third one I can write log of x with the base 5 to the power of 1 over 2 equals negative 5. So we use the rule where we can, if the base is raised to a power, I can write log of x with the base 5. So the second one I can write just 1 over 2 log of x with the base 5. The third one I can write 2 log of x with the base 5 equals negative 5. So now summing them up, 1 log of x with the base 5 minus half log of x with the base 5 plus 2 log of x with the base 5. That's overall 5 over 2 log of x with the base 5 equals negative 5. So I say log of x with the base 5, divide both sides by 5 and multiply both sides by 2. So I get negative 2 on the right hand side. And then use the definition of the log. The base to the power of the answer of the log to the power of negative 2 must equal x. What is 5 to the power of negative 2? So that's 1 over 5 to the power of 2, or just x equals 1 over 25. That's the answer. Let's see another example. Find x. Using the definition of the log, we say the base of the log to the power of the answer of the log, which is x, equals what's in front of the log. 3 to the 2x minus 3x plus 1. Now I'm going to take everything to one side of the equation. So I'm going to subtract both sides by 3 to the x. So I will say 0 equals 3 to the power of 2x minus 3 to the x minus another 3 to the x. So that will be 2 3 to the x plus 1. Now here I can use the factoring rule and factor this as 3 to the x minus 1 to the power of 2 equals 0. And then inside the parenthesis, I can conclude must be 0. So 3 to the power of x must equal 1. Therefore, x must be 0. How did I understood that I can factor this into this? Well, you remember the unions. So a minus b squared, we know it equals a squared minus 2ab plus b squared. So I told you unions are very useful. So here I recognized I have a squared. One of my terms were squared. 3 to the power of 2x, that means 3 to the power of x squared. So I have a squared. Then I notice I have minus 2 times that term that was squared. So I have the 2. And the term that was squared is also right here. 2 times a. And then I noticed I have plus 1. So the plus 1 squared, just 1 squared, that's just 1. So that could be the b. That's how you guess that you can factor that. There are other ways too, but this is more simple. So here we didn't mention all the rules possible, because all the rules can really be derived from the definition of the log. So one other rule I want to mention, and that is
No, please, no more, please.
log of x with a base b equals, you can switch the place of what's in front of the log and the base. If you write it as 1 over log of, now you can write it as log of b with the base x. Why can we do that? Because this is equivalent to saying log of b over x, not over x, log of b with the base x, and on the top I can write log of x with the base x, which is 1. So it's essentially I'm using the same rule that we mentioned before. So this could be very useful in some examples too. Let's see an example. Find x.
One bed, one night, two people, let's solve for x.
First of all, we know what's in front of the log, that is x must be greater than 0, and that's the case always. So just have that in mind. Sometimes you find an answer for x, if it does not satisfy this rule of log, that in front of the log must be greater than 0, you cannot accept that answer. We also know that log of 1 with the base of anything would be 0. So one answer to this, and we know 1 is also greater than 0. So one answer to this equation is that x could be 1. That's one solution. Because log of 1 with the base 5 plus log of 1 with the base 3 equals 0. So x equals 1 is a solution. But let's see if there's another solution here. Now let's assume that x equals 1 is not an answer. Let's leave that behind. So let's say x is not equal to 1. We want to find out if there is any other answer at all. So I know I can write each one of these logs as, instead of log of x with the base 5, I can write 1 over log of 5 with the base x. They are equal. They're the same thing. And the other one, 1 over log of 3 with the base x equals 0. So the benefit of that is that now both of them have the same base. So I can take the common denominator, log of 5 with the base x times log of 3 with the base x, and then on the top you have log of 3 with the base x plus log of 5 with the base x must equal 0. So in order for that fraction to be 0, the numerator must be 0. So the numerator is log of 3 with the base x plus log of 5 with the base x must be 0. And I know this is the addition form, the bases are the same. I can use the product rule and write this as log of 3 times 5 with the base x, or log of 15 with the base x equals 0. So now using the definition of integration, I can say the base of the log, that is x, to the power of the answer of the log, which is 0, equals 15. Does that make sense? X to the power of 0. So x, that's a number, to the power of 0. The only answer to that is a number raised to the power of 0 is 1. So 1 cannot equal 15. So there is no other answer here. That's it. X equals 1 is the only answer to this equation. We cannot find any other answer. Hope you enjoyed it. Let me know if you have any questions or comments.